Hello friends, this is Arti Karnuke, Assistant Professor in Civil Engineering Department at Tulsiramji Gaikwad-Patil College of Engineering and Technology, Nagpur, aggregated with NAC A+ grade. I welcome you all for the first lecture on building construction and material. So basically in this lecture we are going to discuss about the foundation. So as I told you that today we are going to discuss about the foundation. So the very first term is what is foundation. So basically foundation is the element of a structure which connect it to the ground and transfer the loads from the structure to the ground. As you can see, a foundation is the part of a building or a structure which is in direct contact with the ground and which transfer the loads imposed upon it the subsoil beneath. So basically the structure is divided into two parts, whether it is bridge or tower or building or any other structure. It is divided into two parts, like first one is the substructure and another one is the superstructure. So in case of the building, the part which is above the plinth level is called as superstructure and the part which is below the plinth level is called as substructure. So the substructure is also known as the foundation, and it is said that the 30% of the total construction cost is spent on the foundation, because the foundation is the most important part before constructing any structure. The soil on which the foundation rests is called as the foundation soil. So as you see in this figure, above the plinth level called as a superstructure and below the plinth level is called as a substructure. So the foundation is the lower portion of the building, usually located below ground level, which transmit the load of the superstructure to the subsoil. A foundation is therefore so as we know, a foundation is a lower portion of a building structure that transfer its gravity loads to the earth. So the foundation is the lowest part of the building or the structure that is in direct contact with the soil, which transferred the load from the structure to the soil safely. Before constructing a foundation, footing are an important part of foundation construction. They are typically made, so footing is typically made up of concrete with reinforcement that has been poured into an excavated trench. The purpose of footing is to support the foundation and prevent settling. That's why we made footing. So the foundation of a building is that part of walls, piers and column in direct contact with the ground and transmitting loads to the ground. Every building needs a foundation of some kind because of the variety of soil, rock and water conditions that are encountered below the surface of the ground and the unique demand that buildings make upon their foundation. Foundation design is highly specialized field combining aspect of. So if we are talking about the purpose of foundation provided the structural stability from the ground. So the purpose of foundation is to distribute the weight of the structure over a large area in order to avoid overloading and underlying soil, to anchor the structure against natural forces including earthquake, floods, tornadoes and winds and etc. To anchor the structure against natural forces including earthquake, flood, tornado, winds and etc. To provide a level surface for a construction, to anchor the structure deeply into the ground and increasing its stability and preventing overloading, to prevent lateral movements of the support structure. So basically the purpose of foundation is to spread the load from the structure above and over an adequate bearing area of subsoil and provide a stable level base on which to build in. Foundation are required to prevent undue settlement and consequent fracture of the building due to unequal loads and stresses at various points, and to distribute these loads eventually on the over an area. So the basic function of a foundation is to transmit the dead load, superimposed loads or live loads and wind loads from a building to the soil on which building rests. So the following are the 6 points, 6 purposes which are required. First one is reduction of load intensity. Foundation distribute the load of the superstructure to the larger area so that the intensity of the load at its base does not exceed the safe bearing capacity of soil. As we know, safe bearing capacity is the most important part of before constructing any structure. Second one is if even distributed of load, foundation distribute the non-uniform loads of the superstructure eventually to the subsoil. The third is provision of level surface. Foundation provide level and hard surface over which superstructure can be built up. The next is lateral stability. In anchor the superstructure to the ground, thus the imparting lateral stability to the superstructure. Because of the in case of stability is the most important, because the foundation provides the structural stability from the ground to distribute the weight of the structure over a larger area over to avoid overloading the underlying soil. So fifth is safety against undermining. It provides the structural safety against undermining due to borrowing animals and food water. Next is protection against soil movement. Special foundation measure prevent or minimize the distress or cracks in the superstructure due to expansion of subsoil because of the moisture movement in the same problematic soil. So the next is importance of foundation in building construction. Basically, the strength of a building lies in its foundation. The main purpose of the foundation is to hold the above structure, keep it upright. Therefore, it is highly essential to determine the quality of construction when looking for the offices, complexes, outlets, schools for education, office work, and other. So a foundation plays a major important role in the construction of a structure. The basic part is to support the load of entire building. A good and strong foundation keeps the building standing while the forces are nature wreak. The foundation must be built such that it keeps the ground moisture from seeping in and weakening the structure. According to the construction expert and engineer, the foundation must be able to withstand the dead load, live load, and many more. So foundation do not typically contribute to the architecture aesthetic of a building, yet without suitable foundation a building will not function effectively, will be unsafe, and its architectural merits will be rapidly fade. So the design and construction of a well-performing foundation must possess some basic requirement. So these are the 4 requirements. The design and the construction of foundation is done such that it can be sustained as well as transmit the dead loads, the superimposed load to the soil. The transfer has to be carried out without resulting any form of settlement that can be result in the form of stability issue for the structure. Differential settlement can be avoided by having a rigid base of the foundation. The issue are more pronounced in areas where the superimposed loads are not uniform in nature. Based on the soil and area, it is recommended to have a deeper foundation so that it can be guard any form of damage or distress. There are mainly causes due to the problem of shrinkage and swelling because of the temperature changes. The location of the foundation chosen must be the area it is affected or influenced by the future works. So the next slide is foundation load. So basically it is not simple to set up general rules for all the loads for designing foundation. The difficulties to set up general rules for the loads of the considered for designing foundation is due to the differences in local conditions such as earthquake, wind, ice pressure and etc. However, the designer who deals with the study and the design of foundation must be familiar to the loads that may act upon the foundation, either transmitted by the superstructure or applied directly on the footing. If in general the force and the loads that may act upon foundation directly or by the superstructure we are going to discuss here. So first is dead load. Dead load are in general the most important load in the foundation designed particularly for the structure whose footing rests on the soft cohesive soil. Dead loads, being permanent forces action upon the structure, may cause considerable settlement or damages, shear failures. Dead loads is the weight of the structure and it's a permanent part. The weight of the foundation itself and the weight of the soil on the footing are also dead load. In the estimating dead loads for a purpose of foundation design, the actual weight of the construction material must be used. Next is live load. The weight of the structure may be assumed as a live if the weights of the structure may be assumed as a live loads if they are temporarily during a service life. For example, human occupancy, some partition walls, furniture, some stock material and the mechanical equipment in a residential and office building are live loads. Next is wind load. Wind load act on all exposed surface structure. The magnitude of the design wind pressure is the wind loads may be neglected is designing the foundation unless cause loads of foundation exceeding 1/3 of the load due to the dead and live load. Full wind load should be absolutely considered in the design of the foundation of unusually tall and narrow buildings. Next is structural member forces, uplift forces and earthquake forces. So basically in these three parameters, during an earthquake, lateral earth pressure acting upon retaining structure temporarily increase. The parts of the structure below grade, all retaining structure and bracing system are subjected to the lateral earth pressure. Or the type of foundation soil must be taken into consideration in the evaluation of the design criteria. The horizontal earthquake forces in alluvial ground should be taken not less than 3 times those on rock because of alluvial soil and soft drawing tend. So the next slide is selection criteria for foundation based on soil structure. So commonly the selection of foundation type for a given structure is controlled by number of factors. For example, soil type, past site uses, adjacent construction, size of development process, limitation and etc. Among these factors, the selection of foundation based on different types of soil. So foundation are recommended based on the different soil which are provided. Rocks, uniform frame. So the basically soil conditions are like, so the basically deals with rocks, uniform frame and stiff clay, soft clay and peat. If we are talking about rocks, this category involves rocks, hard, sound, chalk, sand and gravel with little clay and dense silty sand, etc. If this type of soil occur, in that case we will provide strip foundation, pat foundation, raft foundation. So for this we have to consider minimum depth of 450 mm shall be used for a foundation if the area prone to frost, so as to protect the foundation. Strip or trench base shall be kept above groundwater table if possible. So in second type, like uniform film and stiff clay if are there, so basically where the foundation, so in that case there are three cases. So case one is if where the foundation is not close to the vegetation, or existing vegetation is not important. So in that case we are going for strip foundation, pat foundation, raft foundation. In case 2, where trees, hedges and shrubs are close to the foundation location, or there a plan to plant these trees near the structure in the future, so in that case we are going for concrete piles supporting reinforced concrete ground beams and precast concrete floors. Second, concrete piles carrying in situ concrete slab, raft foundation. In case 3, where the trees are cut down shortly before the foundation construction began, so in that case we are going for the reinforced concrete pile, strip foundation, raft foundation. If there is a soft clay in this category, including soft clay, soft silt clay, soft sandy clay, soft silty clay, and etc., in that case we are going for the foundation like white strip footing, raft foundation, pile foundation. So as we know that the bearing capacity of soil is the most important part before constructing any structure. A foundation should be designed to satisfy two essential conditions. It must have some specified safety against ultimate failure, and the second one is the settlement under working load should be not exceed the allowable limits of the superstructure. Bearing capacity is the power of a foundation soil to hold the forces from the superstructure without undergoing shear failure or excessive settlement. So we can calculate bearing capacity by these 7 methods, like gross pressure intensity, net pressure intensity, ultimate bearing capacity, net ultimate bearing capacity, net safe bearing capacity, allowable bearing capacity. So here is the some formulation of that for methods. So we are importantly focused on method of improving bearing capacity of soil. So the sometimes safe bearing capacity pressure of soil is low, that the dimension of the footing work out to be very large and uneconomical. In such circumstance, it becomes essential to improve the safe bearing pressure, which can be done by following methods. So first is increasing depth of the foundation. In that case, at the deeper depth, the overburden pressure on soil is higher, hence the soil is more compacted at deeper depth. As a result, it shows higher bearing capacity. This is applicable only for a cohesiveness soil such as sandy or gravelly soil. These methods of improving bearing capacity of soil is not applicable if the subsoil material grows wetter as depth increases. This method has a limited use because with the increasing in depth, the weight and the cost of foundation will also increase. Next is the compaction of the soil. If we compact soil using appropriate method, then there will be in this density and shear strength. As a result, bearing capacity of soil also increase. There are many methods of compacting on soil, like by spreading broken stone, gravels and sand, thereafter ramming well in the bed of trench, then using an appropriate rollers as per the soil type to move at a specified speed, then by driving concrete piles or a wood pile and withdrawing piles. Then the next is confining the soil in this so the next is drainage of soil. In this method, the soil are enclosed with the help of sheet piles. This confined soil is further compacted to get more strength. This method is applicable when there is a shallow foundation, and many more. Next is the grouting material. Grouting, this method applicable for soil where there is a presence of pores or cracks, etc. underneath of the foundation. In this method, poor soil bearing strata is hardened by injecting the cement grout under pressure because its scale of any cracks or pores, etc. For proper distribution of cement grout, the ground is bored and perforated pipes are introduced to the force of grouts. Uh, then the chemical treatment, stabilizing the soil with chemicals. These methods of improving bearing capacity of soil is costly and applied in exceptional cases. In this method, chemical solution like silicate of soda and calcium chloride is injected with the pressure into the soil. This chemical along with the soil particles form a gel like structure and develop a contact mass. This is called as the chemical stabilization of the soil and used to give an additional strength to the soft soil at the deeper depth. So we are discussing, so this is increasing depth of foundation, compaction of soil, drainage of soil, confining the soil, grouting and chemical treatment. So the function of foundation, let us discuss it one by one. Distribution of loads. Foundation helps to distribute the load of the superstructure to the large of the area. Therefore, the intensity of load at its base does not exceed the safe bearing capacity of soil. In case of deep foundation, the superimposed loads are transmitted either through the end bearing or both by side friction and end bearing. The next is the stability. As we discussed earlier, foundation imparts lateral stability to the structure by anchoring into the ground, increase the stability against sliding and overturning due to the horizontal forces to wind, earthquake, tornadoes, imposed loads, live loads and etc. Then minimize the differential settlement. Foundation distribute the superimposed loads even on the subsoil, even in the non-uniform load. This can be achieved by constructing a combined footing or a raft foundation. Safety against undermining. Foundation provides safety against scoring or undermining by floods, water. It provides the level surface over which superstructure can be. This part we earlier discussed. Then minimize the distress against soil movement. Distress or failure due to the expansion of contraction of the subsoil due to the moisture variation in clay and black cotton soils are minimized by the provision of special type of foundation. So the next is spread of loads on the foundation. The manufactured material which is used to carry the weight of the building is usually concrete. So the concrete is stronger than the natural soil which has to support it, so that the forces acting through the foundation may have to distribute it over a wider area of the subsoil to support the weight. So as you see in this figure, how the loads is distributed on the into the ground. So it is usually assumed that the spreading of the forces through the foundation happens within the 45-degree angle from the vertical, as you see in this figure. So the next is settlement. Settlement is also the important part because of the soil having a moisture content. Almost all the settlements of the foundation in soil due to the water between the particles being forced out, enabling the solid particles to pack closer together. After a long dry spell of weather, cracks sometimes appear in the buildings which have stood for many years. So this is all about the foundation. In next lecture we will discuss about the types of foundation. Thank you.